Okay, so what if I told you about an engine with almost no moving parts? An engine that's basically just a fancy hollow tube. Now, what if I told you that same simple tube can push an aircraft to 6 times the speed of sound? Yeah, that's the wild paradox of the Ramjet, and we're about to figure out just how it pulls it off.
You know, back in the day, engineers had the perfect nickname for it, the flying stovepipe. And honestly, it's a pretty great description. Think about a normal turbojet engine. It's this incredibly complex whirlwind of spinning blades and turbines. But a ramjet? It's just a specially shaped tube. That's it.
And that's the big question, right? How on earth can something so mechanically simple create the absolutely massive thrust you need for supersonic, heck, even hypersonic flight? It just feels like it shouldn't work. But the secret isn't in the mechanics. It's all in the beautiful physics of air moving at incredible speeds.
Right, so let's get into it. The magic here isn't in some complicated machinery, it's in pure, unadulterated physics. A ramjet is so clever because it uses the sheer force of the air rushing towards it to do all the work. It literally turns that speed into power. And it's all about the engine's unique shape.
See, the entire engine cycle, the intake, compression, combustion, and exhaust, it's all one continuous, powerful motion handled not by moving parts, but by the internal geometry of the engine itself. It's like a masterpiece of fluid dynamics.
Let's break it down. Step 1, the inlet grabs a huge gulp of supersonic air. Then, step 2, that cone at the front and the widening tube, that's called a diffuser. They force the air to slow down, and when you slow down supersonic air, its pressure just skyrockets. Boom, you've got compression. No blades needed. That means it's lighter, cheaper, and way more reliable. Third, you spray fuel into that super hot, compressed air and light it up. And finally, that inferno of hot gas blasts out the back nozzle, creating massive forward thrust. Simple, right?
But, and this is a big but, this beautiful, elegant simplicity comes with one major catch. It's a problem so fundamental that it completely defines how every single ramjet-powered vehicle has to operate.
And that's the number, 0. That's how much thrust a ramjet produces when it's sitting on the runway. Zilch. Nada. The engine's greatest strength is also its Achilles heel. Because it relies entirely on high-speed air being rammed into it, it just can't start from a dead stop. So you have this classic chicken and egg problem. The engine needs to be moving fast to work, but it can't start moving on its own. So how do you solve that? How do engineers give it that initial kick in the pants?
The answer, my friends, is brute force. You literally strap another engine to it. Most of the time, that means a solid fuel rocket booster that ignites and accelerates the whole vehicle up to speed. We're talking several hundred miles per hour, at which point the ramjet can finally breathe and take over on its own.
And engineers have come up with some really clever ways to do this. You've got wraparound boosters that attach to the side. There are tandem boosters that mount on the rear and then fall away. But my favorite, and probably the most efficient design, is the integrated booster. Here, the rocket fuel is packed inside the ramjet's combustion chamber. It burns away to get it up to speed, and then, voila, the chamber is empty and ready for the ramjet to take over. So with that big how-to-start-it problem solved, this slick piece of engineering was ready for the real world. And its history is this amazing journey that literally goes from science fiction all the way to cutting-edge military hardware.
And believe it or not, the idea is ridiculously old. The writer Cyrano de Bergerac basically dreamed up something like it way back in the 1600s. But it took until 1913 for French inventor René Lorrain to patent a real design, and another 36 years after that for technology to finally catch up and let the first ramjet aircraft actually take to the skies.
And this was it, the Leduc 0.10. Look at that thing. It looks like something straight out of a sci-fi movie. It was actually carried up by a bigger plane and then just dropped. Once it was falling, its huge integrated ramjet would ignite. This was a true pioneer. It proved that a piloted flying stovepipe was actually possible. Now, during the Cold War, ramjets really found their perfect job. Because they were so simple mechanically, less to go wrong, and they were incredibly fast, they were perfect for unmanned vehicles like this, the AQM-60 Kingfisher. This was a high-speed target drone designed to pretend it was an incoming Soviet bomber or missile for the US military to practice on.
And don't think for a second this is just old tech. Far from it. Modern missiles, like the Russian K-31 here, still rely on ramjet propulsion. Why? Because its sheer speed and efficiency make it incredibly difficult to shoot down, proving just how valuable this simple design still is today.
Oh yeah, the list of ramjet workhorses from the Cold War is long and impressive. You have the US Navy's Talos, which scored the first ever missile kill on an enemy aircraft. The The Mach was this massive nuclear-tipped interceptor designed to stop bombers. And Britain's Sea Dart missile proved itself in actual combat during the Falklands War. In every single case, the Ramjet provided one thing: the raw speed needed to catch the uncatchable.
So what's next? Well, the basic idea of the Ramjet, using forward speed to do the work of compression, has inspired some even more extreme and frankly mind-bending engine designs.
So let's meet the Ramjet's even faster cousin, the scramjet. That stands for supersonic combustion ramjet. The huge difference is right there in the name. A ramjet has to slow the incoming air down to subsonic speeds to get the fuel to ignite. A scramjet doesn't. It keeps the air supersonic the entire time. This has been described as lighting a match in a hurricane, and it's a monumental engineering challenge. But if you can pull it off, you unlock blistering speeds way beyond Mach 6.
And the concepts have gotten so much wilder. Get this. During the Cold War, the US designed something called Project Pluto. It was a ramjet that didn't use fuel at all. No, instead it was going to use an unshielded nuclear reactor to superheat the air. The idea was for this missile to fly at treetop level for months, spewing radiation everywhere before delivering its nuclear bombs. It was so insane it was deemed too terrifying to actually build.
And then, if you take the idea to its absolute theoretical limit, you get the Bussard Ramjet. This is a concept for an interstellar starship. The ship would create this enormous magnetic field, miles wide, to scoop up the few hydrogen atoms floating in deep space. It would then compress them until they undergo nuclear fusion, using that raw power to propel it towards the stars.
So think about that journey, from a simple flying tube that broke the sound barrier to a nuclear doomsday machine, all the way to a theoretical engine that could cross the galaxy. The Ramjet proves the unbelievable power of a simple, elegant idea. It really makes you wonder, what's the next big, complex problem that we're going to solve by stripping it all the way down to its simplest possible form?